Welcome to the second part of the differentiation proof videos. This time, instead of just simply explaining the proof behind differentiation, which I'll briefly summarise now, I'm going to give you a question and I'm going to go through how you would use the differentiation proof in order to answer the question. Now, the differentiation proof, as we discussed, was effectively just if you've got 2 points on a curve that are really close to each other, so say we've got x equals 2 and x equals 2.1, how on earth do you find the gradient of that? Now, the curve is y equals x squared. Now, at different points in the curve you might have a different gradient, so it's the question of how do you really find the gradient of the curve. Now, we're going to put this again into algebraic terms, so instead we're going to use, excuse my smaller curve, x and x squared, x plus h and x plus h squared. Now, if you want a more in detail description of what goes on here, simply just go to my other video. It's explained much better, but I just need to summarise this quickly to make sure everybody understands. So y2 minus y1 over x2 minus x1 for the gradient, so it's x plus h all squared minus x squared over x plus h minus x. So it's x squared plus h squared plus 2xh minus x squared over x plus h minus x, which then goes to 2xh plus h squared over h, then it's m equals 2x plus h, and obviously differentiating x squared gives 2x, and as h tends to 0, that's how we know the gradient's 2x. But anyway, that's not the important feature. The important feature is we're going to look at something a bit different. We're going to look at how do you use this in a question. So we're going to look at a fairly standard sort of question. The curve has the equation y equals x squared. P and Q have coordinates 3, 9 and 3 plus h, 3 plus h all squared. Now, this isn't actually any different from the one that we previously did. All we've done is we've just given it a slightly more, we've put it in a slightly more wordy way, which is the way you're going to see it mainly in one of the exam papers that you're going to face at the end of this year, if you're in year 12. If you're not, then yeah, some point in the future. So we're same point as last time. It's 3 plus h all squared minus 9 over 3 plus h minus 3. As you can see, it kind of looks similar to the beginning, but I'll expand everything outwards and make it all crystal clear for you. So it's 9 plus 6h plus h squared minus 9 over 3 plus h minus 3, which goes down to, what does it go down to? Oh yeah, 6h plus h squared over h, and therefore m equals 6 plus h. Now, the first part asks you to find the gradient of the chord in a simple way, and that is the simplest way that is the gradient, 6 plus h. But now it says, hence find the gradient of the curve at point P. Now that's slightly different. The gradient of the chord at point PQ, so effectively what you've got is, to give an idea of what PQ looks like, you have point Q, you have point P, but you need a chord that bisects the both of them, and that's what you're trying to find with the gradient, the 6 plus h. Now they actually want you to find the gradient of the curve. Now, as I've said earlier, h can tend towards 0 when the distances get really small, and that is exactly what happens here. So the answer is just simply, when h tends to 0, m is actually 6. briefly summarise, we've been over the differentiation proof. I'm not going to go over that again. We've taken a question P and Q coordinates 3, 9 and 3 plus h, 3 plus h squared. And then we've put it into the y2 minus y1 over x2 minus x1 method, and then to find the gradient of the chord we've got 6 plus h, and then in order to actually find the gradient of the curve we've simply just made h tend towards 0 and therefore left the gradient as 6. I hope this is useful. Thank you for watching.